Yeah, there he is. Okay.
Unfortunately, we don't own that car.
Just go ahead and cancel that out, huh?
Oh.
I know that projector is hard to read, but I just want to show you just briefly what I know about the Pic Axe. Has a block programming functionality on it too. So if you want to go even one step below basic, you just want to like draw your lines, you know, if this, then that, you know, that kind of thing, kind of similar to Lego. Not as complicated from what I gather, but if you want to at least do something more simple in that way, you can do it. And let me see if I can, let's hear speakers for a second. You can stay there, it's in here. It's been a year or two since I looked at this, but where's it at? Let's see, flow chart.
I think it's under new, Mike.
Is it under new?
Yeah.
Ah, there we go. New flow chart. So you'll get this, and you'll say, for example, here's your start, and you'll say, back in this mode here. Okay, yeah, here we go. If. So you get these symbols here. You can't really read these, but I can say if pin, and I can connect it here, and I can say if pin 1 equals 1 or high, and there's a yes and a no right here that you probably can't see, a Y and an N, you know, then do something else. So for example, let's go back. So if pin 1 is high, how about we toggle something, you know, we put a toggle here, like that, put the toggle there. And then what you can do is draw a line. If it doesn't all match up, you can simply draw a connection point between there and there. So in this simple example, it'd say, you know, if pin 1 is high, do something else. And that's pretty much all I know about it, but I know it's a real cool way to do your programming. The other nice thing about it is when you run the simulation, it'll actually show you in a slow speed way what's happening in your circuit. And then you have a little control panel on the side. You can say, okay, pin 1 is high, like the sensor sees something. And you can see your code change in the flow chart. You know, like this motor will turn on. But then the sensor goes off, now this motor turns on. No, it's real slow, so you can see it.
But I mean, if you hook up your controller, you can actually see like the debugging on this.
That I don't know. That I don't think so. I think you can like simulate the circuit and then put it into the chip and then, you know. So it isn't like a, what's the one on AVR, like an SDK 500, it's not like that.
Which is like a simulator.
It's a simulator.
So basically it shows you what you will be doing.
Right. And yeah, the nice thing about the flowchart thing is you then create the basic code. So once you're done with this, you say save as, and it creates like a real nicely formatted basic code that you can then go from that and learn from that, so to speak. So you can do your flowchart, get a basic idea of what's going on, then go back and look at the basic code.
Visual script over there.
I guess kind of, I don't really have experience with that, but, you know, yeah. So that's the advantage there. I really like it. I just got into the Arduino thing just simply because I want to be able to burn my own bootloaders. I don't want to have to like mail off and get one, you know. So, but other than that, that's really the only main difference, you know. Because most of us have the capability to burn the bootloaders on your Arduino. So if we cook something, run down to Gateway, you get the basic chip they'll have, or get a couple ones. Maybe Rich McDowell has an Atmel or something. Burn the bootloader onto that, you know. So that's really the only advantage on the Arduino side. But this is really cool, so I'd encourage people to check it out. It's really kind of neat. And then Jerry's got a couple boards up here you can look at, just kind of get an idea of what's going on with it. All right, anything else, Jerry?
I don't have anything else.
Okay.
I got one more question.
Sure.
What's the power voltage or whatever, is that like turbo or?
Servos usually take 6 volts.
Well, I have servos that run on to like 18 volts.
Well, you know, this particular one here runs on 6. Since your power voltage for your servo is not running through the micro, it doesn't matter.
Okay.
You just have to have common ground or
What about
it's
the motor?
confused. You what?
What about in like the motor?
Well, this stepper that we were running a while ago, let's see, that's on, yeah, that's running on 12 volts. Yeah.
Depends on your interface. It all depends on the chip, you know, you might have the motor driver chip.
call it.
Yeah.
It's either stepper driver shift, motor driver shift, but that one determines the voltage. They all take 3 to 5 volts input to trip for an input signal, but generally their outputs, depending on the chip, you can get them up to 30 volts.
Yeah.
And the power rating, like 2 amps, 5 amps.
Okay, so basically it's just like a more simple, like a broken down version and you just add on, right?
Yeah, yeah,
Okay.
yeah.
Most microchips don't have that, only put out that 20 and then push it. And when you run 20 mil, you can only probably run about 2 or 3 things until you start exceeding chip dissipation, which nobody really talks about. If you start 4 or 5 LEDs and you turn them all on and run 20